This is the compressor. This is the main thing that part of the air conditioner. Effectively, it compresses the gas. That gas gets hot. Sends it here to the condenser, where it cools off, turns into a liquid under the high pressure. A valve then lets it flow back into the evaporator. This is the evaporator. The evaporator basically expands the current liquid refrigerant, turns it into a gas. It absorbs a lot of energy in the process. It then re-enters the compressor and continues the cycle. As the evaporator cools down, this fan spins, blows cold air over the coils, pulls it in, and then, because this is a centrifugal pump, it shoots it back up and out through the top vents right here. Most of this in here is styrofoam because it's an insulating material. Then the other side, because you have, both radiators. Entirely sure what these radiators are made of at the moment, but I do know that these are plumbed together with copper pipe, which has been brazed to keep it airtight. I will be disassembling this and venting most of this refrigerant. If safe. If not safe, I will not be venting it because it would be hazardous to the environment. It is R110. We will be figuring out exactly what R110 is, R410, and we will make that decision. Welcome back. After some research, we've determined that R410A is a mixture refrigerant consisting of a benign R32 and then a not benign R125. R32 is actually pretty safe. In fact, it can be burned without severe repercussions. It is flammable and explosive in high enough concentrations. R125, however, when burned, turns into hydrogen fluoride, or HF. We will not be releasing it to atmosphere because of that. As HF, sometimes called bone-hurting juice by those who are familiar, is really, really bad to breathe, or touch, or smell, or do literally anything with. So we will not be venting this refrigerant to atmosphere. But we will do our best to determine how this was manufactured and assembled. Mostly here we will be focusing on assembly, as there are many, many parts in this unit. But manufacture of some specific parts will be noted based on a variety of things depending on how difficult it is to access them, with the restriction of not opening any of these hoses for safety. If any of these hoses are open, just for note, the area will be vacated and then approached while wearing self-contained breathing apparatus to either cap the leak or bring it out to an area where it can safely vent without harming anybody. We will continue the disassembly. The first thing to note, this is clearly injection molded. See attached pictures. Mostly to note, there are several spots on this where you can see there may have been an ejector pin. So there's one here, is another here. There may be ejector pin placements here on the fins to allow them to be pushed out of the mold without snapping any of the fins while it is still warm. Let's see if we can find a parting line. I don't see one on here at the moment. But there were most certainly secondary operations to this material. As you can see, there are tapped holes in this plastic, which indicates there was some sort of secondary operation to this plastic. In addition, there were extra injection molded parts in these fins here for directing the air. There consists of several components. To me, it appears there are 1, 2, 3, 4, 5, at least 5 separate components included in each of these grates. The rest is a single injection molded piece. There may have been more with these tapped holes, these tapped sections. These may have been separate and vibratory welded together. That is one possibility. And they're also down here. These sections here may have been welded on with either heat or vibration, because based on this geometry here, there are holes that a mold could not make without parting in a strange way. Either that or having a very expensive piece in the die that would come in and out. I believe the die parted up and down, so it would be mounted in the die like this, where the plane of the die would come in and out like this. And so when, you know, it would have been shot and then pulled apart, and then this would have been ejected this direction and allowed to drop. And then these parts right here would have been added, and then these parts would have been assembled elsewhere and attached. In here, I will disassemble one of these fins to allow for inspection, if I can do so without breaking it. As seen here, this is one of the fins for directing air. This is a rather basic part. It was cast as a single piece. You can see where the ejector pins were on this part, all around the edge of the piece, and then right here in the center in 2 points. The die parted horizontally this direction and this direction to create the finished part. I do not see a parting line on this piece. It is quite possible that this die either had intruding components that were pulled back when the part was produced, or, which in my opinion is more likely, there was a secondary operation to cut these holes. The components on these fins, this is one of them. This is the little tab you use to turn the fin. They attach, it's a simple clip. It was pushed in like this. The second part, this right here, this is one of the attachment points that moves the actual fins back and forth. All of these appear to be injection molded. This one in particular, you can see the ejector pins. This one was simply attached like this. It's pretty free to move in and out. Next, the fins themselves. These are also injection molded. You can see the ejector pins on these, only on one side. In fact, these are quite simple to push in as well. Nope, wrong way. One goes in like this. They snap in like so. The other one goes in the same way, like this. And now you can use them to direct air. I will now disassemble it. It's rather simple. Pull up and out, and they fall apart like this. And then this comes out again. Another component, the filter. This also appears to be injection molded. In fact, I believe it, based on these points here, I believe this to either be a hot barrel injection, or these are points where the screen, this mesh, was fused to the filter. You can see here ejector pins along the edge where it would have been pushed out. Molded into the die was some basic recycling instructions as well as the material. This is made of polypropylene. Based on how flexible it is, my best guess is that this part may not have had any fill. This may have just been either no fill or talcum powder filled. If it was talcum powder filled, it was likely very light. Very little talcum powder was used based on its rigidity. The screen itself, I believe, is made of a metal mesh. No, it's not. This is I believe a nylon. If you look very, very closely, I'm not sure if this is showing up well on camera. It's not. Focus on it. There we go. It's difficult to see, but it appears to be very, very thin right here. It reminds me a lot of fishing line. It feels a lot like fishing line. It looks like fishing line. My best guess is probably nylon 6/6. It seems to be in a somewhat regular pattern. You can see these weird areas where it's like kind of wavy and where they move in and out. I believe that could be the way they were pressed together. I'm not sure though. One guess I have for this is that the screen was created first, cut to size, placed in the die, and then this part was injection molded around it. If that's the case, then that means this was hot barrel weld. This was hot barrel injected. There were no... This part did not come out attached to any risers. It was not cold barrel. The risers were separate, which makes this part a lot easier to produce. But if that is the case, then we do know where plastic came in. Here, 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 and here. So this section filled out quite a bit because it's very thin, and this section had a lot more to fill in with these clips on the end part where it's held. Once again, no parting line is visible. My best guess is the parting line was on this lower edge right here, because it is slightly sharper than the top edge. Oh wait, hang on. It's hard to see right here. Here it is, parting line. There's a small line there. So it is on the lower edge right here. This lower edge. Next. The top hood of the air conditioning unit. This one was interesting. This one was pressed, likely, and bent. My best guess is it was probably done over several steps, and I mean clearly, but using several types of machines. I do not believe it was done with a progressive die. My reasoning for this is, if you look at the size of the bends here, the size of the finished part, a progressive die does not seem like the most likely point here. Progressive dies are best used on smaller parts. This would be an exceedingly expensive progressive die if it is one. Especially considering the number of these units that are produced compared to something that would use a progressive die or deep drawing like a soda can or things like propane tanks and the like. This seems more likely to have been multi-step. However, I do believe that the actual flat stock of this was either a progressive die or a single stamp die. Just big single stamp, was pressed in for like medium right production based on the number of these holes and then these extra bends here for rigidity. You can see here, hard to see, sorry if it's not coming up on camera. Right here you can see these little bumps which add rigidity to the part, as you can see. It's a little harder to bend. Obviously that is also partially to blame because of these bends here. But, and then right here, these cuts, there is some bridging here. This was pressed down and then cut somehow. These were rounded in some way. This was punched through. Right here, these were punched. This, I believe this was punched partially originally as a smaller line, and then a much larger punch came through to give us this bend. This also increases rigidity, prevents these fins from collapsing when pressed on them. Older units that I have seen do not have this lip on the grates. Those are far easier to bend. I do not have an example with me. I do not have a prototype, but I do. I have seen that before. Units like that. Overall, I think initially this was flat, obviously, sheet metal, and then they stamped out these slots, these holes, and input these indents here for rigidity, and put out these screw holes as well in the die, and then after the fact they bended these edges here up and then folded the whole thing to create the final shape. The folding may not have been done at the same place. It's quite possible that this flat section of sheet metal was created at a separate facility, and then the bending happened at the final assembly location. So this was made by another firm. They created all these holes and just left it flat, and then the final location came by with a more simple bending machine and just created all these bends before sending it for assembly. It does appear this was powder coated based on the finish here. The finish on the inside of this metal is actually not very clean. It's actually quite rough. To me, it looks like it was sprayed on and then cooked, powder coated, just because of that texture. The top side has a much better finish. This unit in particular is actually quite dirty, but areas where the original finish is mostly untouched seem pretty even. I would say that it was done, this was definitely laid down flat when it was, I take that back. This was painted after the fact. So this was likely, because the bottom finish here is so poor, my guess is that they folded it Then before it went to assembly, they powder coated it and then cooked it to finish that powder coat. Just because the inside finish is so rough, especially the corners. The corners are a lot worse off than the center. The center actually looks a lot better than the corners here, which tells me that it was likely sprayed on after the bending stage. And then these here, these were stuck on afterwards. Of course, after all this and they had cooled, they added all this padding to the unit. This part holds the capacitor and much of the electronic hardware together inside it. It comes with a diagram showing basic connections for a technician servicing the unit. Today I'm acting as a technician. Oh, I just broke it. That's fine. Oh, come on. Does not want to cooperate with me today. There we go. Put this back in. There we go. This is the main, not the main controller PCB. This consists, there are two PCBs in this. This one, I know this particular section is not part of this class, but I am doing another class about electronics manufacturing, so I figured I'd want to weigh in on the electronic hardware, because I think consumer electronics like this are very interesting because they are made stupid cheap and therefore use some of the oldest electronics manufacturing technology that we have that is not wire bonding. Because this was a PCB. However, to start, I'm going to take this board off just to verify my theory is correct. But something interesting to note about this PCB once I get it through is that I can already see fiducials, which means, like everything else, this used a visual pick and place machine. None of these parts are placed by hand, and they are all surface mount. And just from a preliminary look, my best guess is that this was wave soldered, which just from looking at this, I think that is most certainly true. I can see glue spots. So this looks to be a Type 2 board, which means that the surface mount hardware, well, so first, you can see here there's through-hole hardware on this board. Once I get this open, I will explain all. You don't see Type 2 boards very often anymore. Actually, before we cover our electronics, I would like to cover the buttons and the front panel of this unit. So the front panel itself, as you can see here, the actual decals and everything is a thin plastic layer added after the fact. You can tell because right here there's a membrane and it's got an edge to it, which you can remove if you really want to. I'm going to attempt this. right now. Oh. For one, it has a smell. Not a great smell. Reminds me of PVC, actually. PVC cements. Hopefully this is non-toxic. You never want to be too careful. As you can see, this is a thin membrane. I'm not entirely sure how it could have been formed. My best guess is it could have been, well, it's very, very flimsy, so maybe not vacuum formed, but I could be wrong. This was certainly injection molded. There's a parting line that you can see on the side here. Mostly the lower edge. There's a parting line. This here on the edge, I'm not super confident how these were attached. I believe they may have been added with vibratory welding. But the inside here, this was most certainly part of the regular part, which went this direction and this direction. You can see these here. These are the springy parts, which you use to press the buttons on the PCB. Now that that plastic section is over, we're going to cover the PCBs before we take a quick break. So first, we're going to talk about the controller side PCB. This is a Type 2 board. You can tell because, for one, all of the through-hole parts are on one side. So all of these lights, this display here, these electrolytic capacitors, there's a small rectifier transformer here, and then this pin section. These are all on one side. And there is no green here. There are no traces, nothing, just bridge wires and through-hole components. The other side, however, has traces and solder mask. That's all what this green stuff is. This is all solder mask. And these are all surface mount parts, which means that the first thing that happened was a machine placed all of these on one side. The bottom side crimped these connections or glued them. My best guess is they were crimped. Considering some of them are bent here. You can see these were all crimped. And then on the other side, there was a print process to put down glue to hold down these parts. These parts were then placed directly onto the PCB. Once they were placed, the board was then flipped over once again and then wave soldered. So wave came under the board and touched all of these, the bottom of these pads, to solder them down to the bottom. To prove that this was a Type 2, I can demonstrate that there are, in fact, glue spots under some of these parts. It's kind of hard to see. But if you look really closely at some of these parts, specifically look at the black components. If you notice, between the two pads, underneath the black component, there's a slight spot that may bulge out. You can see one right where it says J10. To the left of that, where it says J10, you can see a little part that's kind of sticking out underneath, like that top side of the part there. That is glue. That was then cured to hold these parts on so that they wouldn't come off when it was wave soldered. And then these are placed down automatically. You can see here there's a fiducial here and a fiducial here. That's for the pick and place machine to get a good XY coordinate on all of the parts. Next, we have our main board, which I will be disconnecting if I can. Okay. We're going to take a short break because I'm getting fatigued. And then I will come back and we will finish pulling this main board off. And once I have some lunch, and we'll get this further analyzed.
Welcome back to disassembly of an air conditioner. when we met last, I was discussing the PCBs of this air conditioner. So we are going to continue discussing that for a short time before we move into talking about the other wonderful and fun things that this unit has to do. Mostly more metal and injection molding. Whee! Don't we love injection molding, everybody? It's only one of the most important manufacturing processes we've perfected in the last, I don't know, years. Don't quote me on that. I know it's not exactly that. Close enough. Where are my pliers? I don't have my pliers. I do have these. So we're just gonna start pulling. Hopefully we don't knock anything over. I don't want to do that. I don't have gloves. Sorry about the birds. They were quite loud. So, the discussion of wiring harnesses. Seeing as this is a commercially built home appliance, wiring harnesses are a staple of the internals where... God, these fucking birds. Sorry for the swear. There's just so many birds. I don't know if they're coming across on video. It's really loud out here. I'm going to try to talk over them. So, wiring harnesses, a staple of modern home appliance manufacturing, where you have a whole lot of wires that need to connect to random boards all over it. And you don't exactly have... You really want an easy way for your personnel to put them on the board. Well, as the book says, in most cases, these harnesses are assembled on site, sometimes using machines that will put them together for you. You just put the ends on them and you get them all together and you're all good to go. Sometimes there are a couple of harnesses that put in manually, sometimes they're assembled off-site. Another company will do it, if you're in the aerospace industry, for instance. The C-130 is a good example. I work on one where, you know, you have all your wire bundles in the aircraft. Little putty here of glue, some type. I'm not entirely sure what it is made of because I am not very familiar with these glues. And of course, zip ties, electrician's best friend. Anyway, wiring bundles. You see them all over in these heavy aircraft. Oh, come on. I'll tell you, this will really give you an appreciation for the strength of through-hole soldered parts. I really wailed on that thing, and it didn't even loosen on that. But it did take the connector off, which is the goal of this whole thing, without cutting myself. Now, I'd say I could take these all to the junkyard and sell the copper, but we all know that there's not enough copper here for that. Okay. So transformer, there are tiny plugs here. Moving. Sorry that I'm not getting a good angle for the camera for this. I don't have a good way to stabilize the camera. Oh, I broke it. It's okay. A heat sink came off. It was glued on. It wasn't screwed on very well. So what's this be? finicky. There's a part here, I think it has been welded on. Oh, not anymore. This is that's the power cord for it. So, like many of these parts, they are secured in place with small black clips that you fit down on top of your release clips so that they don't come out. But they also are there to keep the wires from wiggling. I know we didn't really cover wire bundles in class. That's why I'm bringing this up right now. Home appliances have a lot of them. Alright, there we go. We're going to transformer out now. I'm not sure if anyone other than me is going to see this. I should note that I discussed some of this with my dad in the meantime while we were, when I got back from other things I was doing. And we determined the way a couple of these things were made, namely this. We discussed the possibility that this was laser cut. He doesn't believe it was, nor does he believe it was done with a turret, mostly because of the edges on it. They are not reminiscent of how turrets cut things. He believes it was likely cut in a single step, and then the features of this part were cut in a second step. So likely two-machine process. It is possible it was done with one machine and moved progressively, but that's kind of difficult to determine, and at the moment I don't have any evidence for either. I just do believe that it's more likely that this was done with two machines than a single machine and progressive die. But that kind of depends on how many units of this air conditioner they produce a year. I don't believe it's a whole lot. Obviously, people need air conditioners in hot places, but you know, they're not like, it's not like an iPhone or like a, I don't know, it's another part that you make a billion of, you know. You're not making a fuck ton of these. Excuse my language again. Apologies for swearing. I am not on the clock right now, and I'm in my own private domicile, so I do that. But this video is, I don't know if I'm going to edit this video down at all for any potential watchers. Maybe I'll link this in the paper. Let's see. I'll be doing a more, I don't know, more or less thorough analysis of some of these components in the paper. But from what I've been able to do, mostly by disassembling this, is prove that much of this system was assembled, and then a lot of these things were strapped in place with screws, which, for a process that's not great, that's a lot of time that they're wasting while assembling this. There are a lot of screws that could instead, things that could be, that are instead secured by screws could instead be secured by clips. A great example, circuit boards. These, I have seen it all over the place. Literally, the computer in my basement, when it was originally assembled, used a set of clips that were in the back of the housing to hold the motherboard down, instead of screws. Currently they are held down by screws because that's how I built it, but this very easily could, and in my opinion should have been held down with clips, plastic clips, which you can manufacture en masse. Okay. that's it for this housing. We're going to take this housing off now. Again, it is screwed on instead of some other method like rivets or what have you. Wasting as much time as they possibly can on the factory floor. Time that could be better something else. But for me, as somebody who likes to take things apart, I prefer screws. I prefer them because it makes it easier for me to disassemble things. Screws and clips, those are the two. Clips, I like because you can actually still disassemble something versus rivets where you have to drill everything out. Screws are nice because you can put them in and out as many times. Clips will break sometimes, but it's still better than nothing. Or bend. Those are scary for me. Right here, there's a small sensor that is placed on the front of this radiator here that I pulled off earlier. It is zip tied to the copper here. I will be covering that soon. It appears there's another sensing line here. So here we have the metal housing for the main circuit board. I will bring this closer to the screen so you can see it. Hopefully, okay, it has been focused on this the whole time. Just checking. So I have not finished disassembling this. There is a capacitor right here. You can see it. Mostly to correct for the power factor on this one. This one is a... Let's see if I can get a good angle on the sun. Can you see it in there? There we go. Looks like... Let me see if I can read this. 35 microfarad, so plus or minus 5%. It's a decent sized capacitor. Honestly, it's definitely more than you'd see in a microwave, but the voltage rating is actually a lot lower than the ones you'd see in a microwave. So, you know, pretty decent all things considered. It's about 240 volt cap, peak. So that's about right. Not peak. That's RMS. Excuse me. On the back here, you see something interesting. There is aluminum tape on the back of this. What is it covering? Well, for one, it appears it's covering a hole here, but also there's two holes here, and then there appears to be some spot welding. This spot welding is right here on this section. Now, I'm not sure why. It's possible the spot weld didn't go quite as well, like it's stuck, but it's not like electrically connected. Or they thought it would be unreliable or bad at keeping RF in. That's possible. Right down here you can see here's another spot weld where they connected the bends together. So this one seems to have a fairly complex bend. I think this was done with more like a turret and bend system. Then I think it was a more discrete machine that they would program versus something like a die. I do not think this was... it may have been initially die stamped to get the shape, but based on the cut, the way the cut is, I don't think that's the case. It may have been... I think it may have been cut using the same machine that was bending it before. I could be wrong. Either that or laser cut. But that is my theory. And then there's another section on the back here that was tacked on. So that is this part. And then here we see there is a section that screws on with the capacitor. Really jammed it in there. Got it out. So here is, you can see the capacitor here. I think this was deep drawn. This was run through, it was deep drawn to create the bottom shape, and the top of the can was pressed very similarly in a way that they do soda cans. I forgot the name of the process, but yeah, I believe that is the case. And these were manufactured separately, these terminals. Obviously, with a capacitor like this, you manufacture basically the internals and the cap all together, and then you press them into the bottom of the bowl. So that's our thing here. And then we can have a look at the tray. I think we'll hold off, but the tray on the inside here was also injection molded. The tray holding the PCB is definitely injection molded. Let's cover the wiring harness real quick. I have it right here. What did I do with this? Grab a screw. Bastard stabbed me. It's okay. These things have teeth, and they do like to bite. Alright, so at the moment, keep heads clear, terminal area uncovered. You know what I think I'm going to do? I think I'm going to remove this cover. Get at it. Alright, I'm unable to get into the cover, but as you can see with the wiring harness here, so this is the cord. Produces some length of wire, stranded with an injection molded backing on it. There is a set of buttons on the back here, you can see, for setting the internal breaker. I believe it is a breaker, not a GFCI. I could be wrong. I have not tested that aspect. And then this part was injection molded, again, like everything else here. I'm not sure out of what though. It appears to be clearer than the others. In my opinion, it looks to be more susceptible to heat damage, so I don't know why you put that in something that gets hot, but again, just my limited assessment. And then the wiring harnesses themselves, I mean, they're a little bit of a mess now because, I mean, I pulled them apart getting this ready, but they're all color-coded for a theoretical operator to put them all in together. I'm not sure if they were zip tied together at the factory. They may not have been, based on how organized these are. They're not like nice and neat with like straight lines and everything. It seems to be a little more of a spaghetti mess. Even when I looked at the compartment directly before, you saw on the video, it looks definitely a lot more like spaghetti than a nice, neat electrical bundle that you'd see in a plane, for instance. There's a transformer here for dropping it down to about 10.5 volts for the low voltage electronics. And then there's a high voltage side for your power to your compressor and your fan, which is right here. You see it spins. So when you give it a good blow, you can feel the air on it. I will be recycling this when I'm done, of course. Alright. Cut off this, or rip off this sensor. Not having a good day, are we? How about this? I'll just brush and twist it. There's our sensor. Next, let us discuss the insulated section. So there's a hot side and a cold side. So your evaporator and then your condenser. This right here is 2 parts. This is the top section, and then there is a bottom section that I don't think we're going to be able to get to during this because of the refrigerant that is in this. I don't want to, again, as stated earlier, I don't want to deal with refrigerant, so we're not going to. We're going to try to do as much of this analysis as we can without that. This part is polystyrene. I believe it to be injection molded. I'm thinking, trying to see if I can find a parting line. I think I found it. So, parting line is about there. I don't know if you can see it here. So, the parting line is this bottom edge right here, all the way around. It's hard to see on this part in particular. It looks like right here it goes down around the bottom edge. And I think it does continue like around in this area before moving up right here, take in this section. I may be wrong just because this edge is really sharp, and I don't really see a whole lot of other spots for this for the die to be running. It just does seem a little tall to me. But it is clearly, some of this somewhere is where it parted. But it definitely parted like this direction. There's all these little tiny spots on here, of course. And then I believe, so these are the ejector pins. And then I believe this may have been hot barrel right here. I think this is hot barrel. There's another ejector spot right here beneath the tape here, but that's my guess. I believe, yeah, there's a spot here for some to come in, a spot here and a spot here. I think it's hot barrel based on the shape of this ring. It may have been cold, but I'm gonna vote that it's probably a hot barrel injection. Considering if you look at this really close, it doesn't really have the same. It is still styrofoam, but it's not like super frothy. It's pretty well packed in. So it's definitely injection molded. Put this down here. A little fun fact about polystyrene is you can dissolve it in acetone, which actually makes it somewhat easy to remanufacture. If I remember right, there's a lab that did it once that got a 60% yield back out of that styrene when it converted it back to its monomer form. All right, let's cover the scary bit. At least for me right now, because of the copper. We're going to unscrew this a bit so we can have somewhat of a better look, but I won't be pulling it too much because of the refrigerant. But we're going to look at our evaporator. The evaporator is on the cold side. The evaporator and the condenser, both of them, are appear to be built the same way. This is copper, so we're just going to bend it. Just making sure we're not leaking. So, I will take good pictures of this when we're done. Clearly, it's made of several parts that were brazed together. So these tubes on the end were inserted after the fact. So the centerpiece was made all at once. All these fins were stacked together. I think they were pressed together, it kind of looks like. It looks like it was single tube, and then they pressed them all and stacked them on top of each other. I don't see evidence of brazing on this one. I know, Professor, you were excited about car radiators that were brazed like that. I may be wrong, but to me, I don't see any significant evidence of brazing on this particular unit. Granted, this is not a car. And the radiator fins are definitely a bit different, and they have a completely different purpose in the car than does in this. I mean, it's effectively the same sort of the same job here, but I just don't think it was brazed. I'm not entirely sure what process it was. I do think the fins themselves were definitely cut out of something, definitely stamped. My guess it was probably, it could have been a progressive die. I know, I keep saying progressive die over and over and over again. Oh, I think it's a progressive die. This one I think it was just because of how many fins they need to make compared to things like this where it was just a single stamp, and that top cover where there's just not the volume there needed to to say that you'd want a progressive die. This one, there would need to be volume. They're two different sizes as well, so that kind of, to me, rules out that they were the same part. They're definitely different parts, but they may have interchangeable parts. These fins may be one of them. They may just like cut them to length for different ones. These tubes were inserted after, directly into the sides, on both ends here. Here you can see though, these were definitely brazed based on the colors. Here they weren't, which is interesting to me. It looks like they were just kind of like pressed in maybe. It's hard to tell. Maybe there was some other trickery they did, but it looks like on the production line, when they built this, that the operator sat on this side. Everything was done at the final assembly line from this side. Nothing was inserted from the other side. Maybe there were a couple people on the other side to add things like this tape here. And maybe to put in a few screws, but most everything done with the major components, like installing all these hoses and putting in all the wiring harness and everything was done from this side of the unit. My reasoning for this is this side, there is no brazing on any of the pipe. There is none. It's all on this side. So they brazed everything on this side and ran all the pipes here. The compressor is here, the pipes are here, all your joints are, your sensors, and your electrical is all on this side, compared to the other side which has nothing. Just this one strip, which seems to suggest that someone had to install that sealing strip on that side. And then these plates were installed prior to the copper, I think. I could be wrong. Maybe they did actually, maybe they had a crimping device to rotate them and put them down. My theory here is that most of this stuff on this side was done at the factory, and this stuff was done at the place where they assembled the radiator. I believe the this condenser, I'm sorry, I keep calling the wrong thing. This is the evaporator. That this evaporator was assembled at a different location than everything else. Clearly, because that's how supply chains work, but this was done somewhere else. And then everything here was brazed and assembled based on the quality of the braze, the quality of the metal, and the corrosion was done at the assembly plant where they made the final build. Moving on right here, it's hard to see on camera. Let me rotate this slightly so you can actually see it. I don't know if you can see, but right here, there's a tube, and it looks crushed and bent a bit. This was attached to something else. This was your feed line. So to insert the refrigerant during final assembly, this is the last thing they brazed. They filled this with refrigerant, cut the unit off, and then covered it with, they flattened it so nothing would escape, and then they brazed it shut. You can see there's a drip here with the solder and everything. The nasty, disgusting corrosion and everything is all on that side. The condenser unit on this back side here, which I'm not going to fully rotate to show you, is very, very, very similar to this one. It's just bigger. It's just a larger unit, more fins, more tubes. Same thing goes for here. Most of the nasty corrosion and brazing happened on this side, not the other. The other side is very clean and nice and orderly. This side is kind of a bit of a mess. There's a bunch of T's in weird places. I think specifically to get the thermal conditions that they wanted, they had to set it up like this. But that's my current thought. In terms of assembly, I think that the unit was this section, the motor. We're going to discuss the motor now. I can't pull this out for obvious reasons. Again, I don't want to break any of these. When you cold work copper too much, it will become brittle and it will snap.
I don't want to deal with that right now. I don't have a way to anneal it, as you can tell. But there are screws down in the bottom, right here, both sides, where the motor, this whole housing, this housing is attached to the bottom here. This was injection molded. You can see the ribbing here, and there's a bunch of geometry that is only possible through injection molding. I'm trying to see if I can find any risers. I don't see any at the moment, where the risers would be, or any push pins. But they are likely on the other side. This side is very smooth. It's a very shiny finish. It's likely behind our condenser. So the motor with nothing on it was installed first. It is then bolted via, it's got the flange on it in the back here. It was bolted to this injection molded part on its own as an assembly on its own. It is then the fan blades, both sides are attached to the motor and its shaft by hand. They are screwed on, they are not snapped on. Everything is screwed and bolted here. There is very little that has been with snap-ons or rivets. Most everything is either spot welded together if it needs to be joined, or it is screwed together. There are the only snap fittings on here are with the electrical connections. These are the only ones that have snaps on them. Once this assembly is together with all the fans, everything is then, that is taken to the main assembly line. Here, it appears initially this bottom tray, which looks to be a deep drawn piece of sheet metal, mostly because it's rounded on the edges here. There aren't any spot welds, and it's just a big sealed tray, no holes or anything. So I believe this was a deep drawn, progressive die, something like that. Again, sound like a broken record here. So I think that was deep drawn, and then the next part that happened was these were placed in. Both of the radiators, take it back. First, this lower piece of styrofoam was added. There is a lower piece of styrofoam, very similar to that top piece, completely different shape. Also injection molded, you can see the lines and everything where dies were departed. That is placed in the bottom first. Then these two are, at the very least, this one right here, the condenser is placed in first. Once the condenser is placed, the motor and the fans their assembly is placed on top. Right here, they're placed right in this styrofoam groove, and then this housing goes over the top of the condenser unit. After that, I believe this was added and this was bolted down. All of this copper is likely pre-bent and ready to be assembled. So these were just left in, and their wiring harnesses were left laid out on the ground. So let me move this back in without cutting myself. We're going to leave it like that. I believe that this section was also pre-assembled with most of the wiring in this already. So the wiring already came into this. Some of this was left already hanging out. These two ones, this white and black one, these were left out, but the rest of the wiring was already in here. So this, along with its PCB right here, was, let me see if I can set that back. Like this. This was installed. This was installed next, along with its capacitor and everything right here. Then afterwards, this was placed on top. We're just going to put it in rough like that. The wires were hooked up. This plate was placed on and screwed in place. Before that PCB was done, though, so before any of this happened, when this was put in place and then this was bolted down, all of this copper, which was pre-made, was put in. Then they put the PCB in like this. They connected everything, put the plate on. Then and they put the sensor on and everything. This was left open, I believe. So this was this was not put on yet because they still had to put this on. So this this section is not screwed into this yet. So this is kind of left hanging here, but this is connected first. And then the plate is closed once this is connected inside this guy, which is also another assembly. That's all screwed together. Then this guy comes out. This thing was also pre-assembled with all of our little parts, as you can see here, into this larger final assembly. I think that this filter was already in here before everything was put together. So this filter was in here. Then once it was ready, they came out. Once everything else is put together and everything is connected, they bolted this to the front plate and then put this on the top. So we'll just put this guy here, and then this is placed here. Ignore that. And then the final part, final step of the assembly, they took the top cover and put it on top. That is how I believe this was assembled. So, to recap, the sub-assemblies needed here. We did not go over this. I will cover this in more depth in the paper. These things have their own fascinating history about them and internals. I'm not going to show them here because I don't have a way to dispose of the refrigerant. If I did, I promise you I would absolutely be tearing into it right now. Because I really actually want to see the internals of this too, but unfortunately I am unable because I do not own a fume hood or a way to dispose of it safely. So, effectively, the sub-assemblies here involved are these things. These were assembled with all their small parts together and placed into this large section. A second sub-assembly is, where did I put it? Right here. This was a sub-assembly that was placed all together. It may have already been assembled with this full thing, which is the other sub-assembly, our third one, which included much of the wiring harnesses, its PCB, and the capacitor, which was placed in here. Two more sub-assemblies, the condenser and evaporator. Both of those were their own sub-assembly. The tubes were effectively are another harness. You act with these tubes as you would with the wiring harness. You pre-bend them and you have them in a pool that you can just kind of pick up and graze on when you're ready. Another sub-assembly, this backing with the fans was all assembled beforehand, before the final assembly was and then put in. These two are not sub-assemblies. These were made individually, both injection molded, both styrofoam pieces were injection molded. And then in terms of how it was put together, again, recap, the base plate was placed down, this first styrofoam piece was installed, the condenser was installed, and the condenser was installed, the evaporator was installed, this piece was put on top probably the same time as the evaporator. This was bolted in, everything was brazed together, then they took this and all of its components, put it in, wired them together with this guy, left it hanging, then kind of like put it up in place and put this front piece on, I believe, or I'm sorry, yeah, they put this front piece on, kind of right here. No, I'm sorry. They left this hanging up front. Then they put the top on, the big sheet metal top, and then they bolted this on the front. That is how I believe. Bolted this to this, and then this to the front, and then you have a completed assembly ready for selling to somebody who is has their own broken air conditioner and need a new air conditioner, I guess. Did you ever think about that? Just an extra thought I had. That most people only ever really buy an air conditioner when there's breaks. Have you ever had to like buy a new air conditioner because you didn't have one already? Most of the time you buy an air conditioner because one, you don't have enough in your house, or two, the one you had broke.
Very rarely are you buying one on its own. Granted, I mean, isn't it like that for every appliance? I mean, no one ever buys a new, like, fridge or washing machine or something. You always buy one because the one you had that was in your house or apartment or wherever broke. You buy a house, your stuff breaks, and you just buy a new one. I don't know. Just a thought. Anyway, we will now be taking pictures of the specific parts so we can discuss them further in the paper. That should do it, I think.